Hi Jamie, this is David. On this particular question here, our only choice to solve this problem is by using Excel, and we're just going to have to tabulate and use Excel. So let me show you how you can do that. It's kind of involved, but if you try to use StatCrunch to do this using the custom calculator function, you're not going to get the exact answer. It's not going to round correctly, and I think it's because of the fact that it's comparing a population to a sample, and that's what's causing it to be off. So the first thing you need to do is you need to find the midpoints, and the way you do that is you take each interval, for example 30 plus 39 divided by 2, and that's going to give you 34.5. 40 plus 49 divided by 2 is 44.5, and so on. So these are the midpoints, these are the x values of each of these intervals that you see here, and then here are the corresponding frequencies. Now what I have to do is I have to basically construct the components of this equation here. So the first thing I want to do is take the midpoint x and square it, and then copy this formula down the page, and then I want to multiply each frequency times each x squared term, and that gives us this, and then copy this down the page, and then multiply each frequency times each x value, and then copy this down the page. Okay, and now I have to sum f(x squared). So I'm going to come down here and do summation of f(x squared), and that gives me this result. And then I have to sum fx, the products of fx. So sum this column here, and that gives me this term here. And of course n, I can sum all the n's to get all the n's here, and n is 92. So now I have all the ingredients here to construct this equation. So n times I should say the sum of fx squared, which is this number right here, minus the sum of fx squared, quantity squared, and then put parens around this. We need to put parens around everything here. And then I'm going to divide that by n times n minus 1. And just for good measure, I'm going to go ahead and put parens around everything you see here. So this is the denominator here that I'm constructing now, and hit equal, and I get this result here. So this is the variance. So to find the standard deviation, take the square root of this result, and that gives me 13.76, which rounds to 13.8. 13.8. And we get it. Okay, consider a difference of 20% between the two values of a standard deviation to be significant. How does this computed value compare to the 11.8? Okay, well, in order to be able to do that, I have to take 13.8 and subtract it from 11.1, and then divide that by 11.1, and I get 24.32. So these two values are 24.32% apart from each other. So therefore, the computed value is significantly greater than the given value. Thank you.